Shanmugamari from the Department of Information Technology. Today I am going to demonstrate Naïve-based classification algorithm from the data science. Okay. From the machine learning, there are the two categories of learning. One is the supervised learning, another one is the unsupervised learning. We can say what is the supervised learning. The labeled data are called as the supervised learning. The unlabeled data are called unsupervised learning. Okay, so the hybrid model means it includes supervised and unsupervised learning. Okay, so first of all we are going to see the supervised learning. So you can see the girls, you can see the diagram. From the supervised learning, which is the model, they are trained by using the labeled data. So we can see the diagram. From the labeled data here, there are the three labels. There are the three images are there. One is the cow, second one is the elephant, the third one is the camel. From the supervisor, we are giving the training data set as labeled. Then we can choose the appropriate algorithm for the classification. This is called supervised machine learning. The labeled data is the data that has been tagged with one correct answer for the classifications. Once the training is completed, we'll test the model by giving the new set of animals. The model will identify the animal and predict the output by using the suitable algorithm. This is called supervised learning. The next one is the unsupervised learning. We can see the diagram. In the unsupervised learning, there are the raw input data. There is no label. Okay, so unsupervised learning is another machine learning method which importance infer from the unlabeled input data. So the goal of unsupervised learning is to find the structure and pattern from the input data. Okay, so unsupervised learning does not need any supervision. Instead that find the data from its own. So we can say that there are the group of elements camel and cow. There is no label. By using our algorithm, we need to interpret and we need to classification and predict it. Okay, so here we are using the Naïve-based algorithm is one of the supervised learning algorithm which is based on the Bayes theorem, and it is used for solving the classification problem. It is mainly used for text classification that includes the high dimensional training data set. Naïve-based classifier is one of the simple and most effective classification algorithm which helps in building the fast machine learning models that can make quick prediction. Okay, it is a probabilistic classifier, which means it predicts on the basis of probability of the object. Some popular examples of the Naïve-based algorithm are spam filtration, sentimental analysis, and classifying the articles. Okay, so why it is called Naïve-based? Naïve-based algorithm is, there are the two words. One is the Naïve, another one is the Bayes. Naïve is called, it assumes occurrence of the certain features. Okay, for example, if the fruit is identified on the basis of color, shape, and taste, then we can recognize as the apple. For example, apple, we can say occurrence of the shape of the color is red, is a spherical, that is the sweet fruit. So we can recognize as maybe a apple or as maybe a tomato. But tomato is not a sweet, so we can say that is the apple. Okay, so hence the feature is individually contributes to identify that is an apple without depending on each other. The Bayes it depends on the principles of Bayes theorem. Okay, it is which is used to determine the probability of hypothesis with prior knowledge. It depends on the conditional probability. Okay, now see the formula. Probability of A by B, which is equal to probability of B by A into probability of A, which is divided by probability of B. Probability of A by B, which is called as the posterior probability. Okay, so probability of B by A is called likelihood probability. Probability of A is called prior probability. Probability of B, which is called marginal probability. Okay, so now the working Naïve-based classifier can be understood with the help of with the help of the algorithm. So I'm giving some data set. I'm giving the data set for the weather conditions, and corresponding target variable is play. We are going to find whether we can play or not according to the weather condition. Okay, the first of all, there are the 3 steps to follow the Naïve algorithm. First one, convert the given data set into the frequency table, then generate the likelihood table by finding the probability of the given features. Okay, now use the Bayes algorithm to calculate the posterior probability. Okay, see girls, you can see the data set. This is the data set, outlook data. This is the data set, outlook data set, and there are the 14 items are there from 0 to 13. There are the outlook, that means there are the categories. Here there are the 3 categories are there: rainy, sunny, overcast. There are the 3 categories. Whether we can play on the rainy season, yes or no; sunny season, yes or no; overcast season, yes or no. Okay, could you understand? This is the data set. Now we are going to find whether the sunny season the player should play or not. Okay, the player should play or not. This is the data set. Okay, so first, what is the first step? So please find the frequency table for the weather condition. Okay, so here what are the 4 conditions for the weather? Overcast, three weathers: overcast, sunny and rainy. Okay, so we are dividing the 3 categories: sunny, rainy, overcast. You see the table. Okay, so from the overcast, how many places of yeses and how many occurrence of the no. Okay, so how many occurrence of overcast yes is 5, no is 0. So just you count it, that's it. So rainy for yes 2, rainy for no is 2. Sunny for the yes is 3 and sunny for the no is 2. Just you count sunny for yes how many, sunny for the no how many. Okay, so total number of yes is 10, total number of no is 5. This is called a frequency table for the weather condition. Okay, then next we are going to step 2, likelihood table. Likelihood table means from here. See guys, you listen. From the overcast, there are the 5 yes and 0. There are the 5 yes and 0 no's. So total number of occurrence 14. So we can say for the overcast, 5 divided by 14, probability is 0.35. Okay, could you understand? From the rainy, how many yes and how many no? 2 yes and 2 no. Total number how many? 14. 14 divided by 4 divided by 14. So probability is equal to 0.29. Sunny, how many yes? 3 yes and 2 no. 3 plus 2 how much? 5. 5 divided by total number of data set 14. So probability is equal to 0.35. Okay. So next. You please find for the yes and you can please find for the no. Yes means 5 plus 2 7, 7 plus 3 how much? 10. So 10 divided by total number of 14. So is equal to probability is equal to 0.71. For no, how many? 2 plus 2 4. 4 divided by total number 14. So how much probability? 0.21. This is likelihood table for the weather condition. Then next we are going to apply the Bayes algorithm. What is the Bayes algorithm? P of A divided by B, which is equal to P of B divided by A into probability of A, which is divided by probability of B. Okay, so from B for B, here we are going to apply for the sunny. Whether the weather condition is sunny, we can play or not. So so we can apply for the A. We can apply for the A for yes, sunny for B. Okay, so for yes divided by sunny is equal to P of sunny divided by yes star into P of yes divided by P of sunny. Okay, so how many? So we can this is we can find finally. So first of all, we are going to find probability of B divided by A. Probability of B sunny is divided by yes. So sunny divided by yes how much? 3 by 10. Sunny how much? Yes, 3. So, okay, total number of sons, how much is 10? So, upper 3 by 10. Upper probability is equal to 0.3. P of sun is equal to, from we can say the previous, P of sun is equal to 0.35. Okay, see here, P of sun is equal to 0.35. P of S equal to, see the probability, P of S how much is 0.71. Okay, P of S equal to 0.71. So, P of S divided by P of sun is equal to, what is the probability? 0.3 into 0.71. 0.71 is P of S. 0.35 is P of sunny. So, which is equal to posterior how much? 0.60 for the P of sunny yes. Okay. For the same rule we can apply for the P of sunny for the no. Instead of yes, we are going to apply for the no. So, no means P of sunny divided by no, we can apply 2 divided by 4. 2 divided by 4. What is the result? What is the probability? 0.5. P of no how much is 0.29. P of sunny how much? 0.35. So, probability of no how much is 0.41. Okay. Whether the condition is sunny, so probability of yes equal to 0.60. Probability of no 0.41. Which is greater? 0.60 or 0.41, which is the greater? 0.60 is a greater. So, we can see from the above calculation P of sunny. So, the player can play the game. Yes. Okay, so the result is 0.60. Likewise, we can apply our original data set to the naive Bayes algorithm, because you can understand what I am saying. The sunny season, the sunny weather condition, we can play or not. For the sunny season, if S, what is the probability? 0.60. For the sunny, no, how much probability we find? 0.41. So, you can see from the calculation, from the sunny season, we can play yes. Okay. So, what are the advantages of the naive Bayes algorithm? Naive Bayes is one of the fast and easiest machine learning algorithm to predict the class of data set. It is used for binary as well as multi-class classification. Okay, it performs well in multi-class prediction as compared to our other algorithm. Okay, it is most popular choice of text classifications algorithm. The only one disadvantage, it assumes all the features are independent or unrelated. It cannot learn relationship from the features. Okay, these are the applications. It can be used for the credit scoring, used in the medical data classification, can be used in real-time prediction by using the naive Bayes classifier algorithm. It is used in text classification such as filtering and sentimental analysis. Okay, so this is the class on today, naive Bayes classification algorithm from the data science. Girls, you can understand the algorithm easily. Thank you.